All right, here's our problem. Element alpha, we have a half-life of 30 years, and I know that the model that we're looking at for some amount left over is going to be AE to the KT every time. Anything exponential, this is what it's going to look like. After 30 years, we have some amount left. Why did I choose 30 years? It's a half-life. Alternatively, I'm going to make the claim I could have chose 60 years, but my number would change. After 60 years, I have 1/4 of the original amount. After another 30 years, it's another half of that. Every time it just cuts in half. So looking at this, I've chose 30 years because I am able to calculate out half of the initial amount. Now looking at this, we want to solve for k. Unfortunately, it is stuck within the exponent currently. If only we had a way to undo exponentials. Take the log, and I even heard somebody say take the natural log. Love it. And we're going to make note of something that happens. I'm going to switch to blue because we're changing colors. I'm going to do the left side. That's 1/2. Anybody opposed to me doing that? You could write 0.5 if you wanted to. I took the natural log and I just simplified this down instead of writing it. You could keep it 6.5 out of 13 if you want to. Equals 30k, and I'm using my exponent property. And I'm not even going to bother writing the other part. But if you want it, what's the other part that I would write here? The natural log of what? Why don't I write this? Say it again. It's 1. That's just a 1. And I multiply by 1. One more step. If I want to solve for k, last little piece. I'm going to divide both sides by what? All right, so check this out. Natural log of 1/2 over 30. This is a number. When you type this into your calculator, do the parentheses matter? Big time. Huge, huge, huge. Let me know what k is. 0.023?
Right?
I don't know. I didn't check.
Negative 0.2310.
0231? Okay, I'm fine with that. Somebody seconds and thirds and fourths? Okay. All right. Now that we know k, I have this taken care of. Do we know a?
Yeah.
I have that taken care of. T is the only variable in this thing. Cool. If you want to call this a of t instead of y, it might make more sense, the amount at time t. Whatever you decide to write for that left side doesn't matter to me. I'm typically going to use y, or depends on the context. But let's check it out. Do we have enough information now to make a working model? Or a functional model? Functional function? I don't know. I'm just going to make a couple things. We have a model that works. I don't know why I used a dot there, but that's okay. We know that the equation is going to be y, the amount left at time t, y of t is what I'm going to refer to this as, equals, what's my initial amount? 13 grams times e to the k we just found out was negative 0.0231. And this works for any t value that we pick. Do I expect you to do 13 times e to the negative 0.0231 ever? In your head, at least? No. If you had a slide rule or a fancy book of logarithmic values, you could do this. Alternatively, you guys have an opportunity that most of humankind did not. How are you going to evaluate this? We're asked to find the amount after a century, right? So we're really trying to find y of what number? Y of 100. And everybody's using your calculator, which is what I would do. This is 13e to the negative 0.0231 times 100 in your calculator. Or if you know how these are going to work, you can just move the decimal there nicely. Give me an amount for after a century. I can already tell you 100 years is pretty close to 90, so I'm expecting it to be what? 3 1/4, a little bit less than 3.25. And then follow-up question. I'm going to come around and look at your calculators just because I'm curious to how you did it. Reasonable. Reasonable. Can you go get drinks, Sean? Feel free to do so. Make sure you know how to do these. We're still, oh, you got this? 1.29. Sorry about that. Okay. So something weird happened. Let's see. Where's this 100? So check it out. We're just going to do second enter. And then I'm going to delete this 100 because where's it supposed to be? If we look at the equation. Times 100 there. Yep, and good. Not everybody did. I appreciate it. Cool. What do we get? 1.29. So I was a little bit off on mine. That's okay. What's the actual answer? What does this mean? 1.29, so what? After 100 years, we get 1.29 grams of element alpha remaining. Okay. Hopefully kind of easy. It maybe not. There are some natural extensions that we can make on this though. Turns out I can have you solve for any part of this as long as I give you a little bit of information, and that's pretty cool. Before we jump in to another, gosh, I use that all the time too. Before we hop into another problem, run in, I don't know. I want you guys to make a big important note in your stuff. For radioactive problems, everything radioactive, how long it lasts, we always refer to it with the idea of half-life. Which means if you ever are given the amount of time in a half-life, it's super duper easy to plug in one full half-life and you have half the amount left, right? Which means no matter how much we started with, after I do this problem and I start trying to solve for k, I'm always going to have a 1/2 right here because I'm just going to divide the initial by the half of it now. Sorry. The amount, I'm going to take half of it divided by the original amount because it's always going to shake out in the calculation. What's this 30 with our problem? 30 years, and that's the what of element alpha? Good. A little bit more specific. And that's maybe not. It's the half-life, right? For radioactive, and I'm going to write this nicer, and this will always be the case. For radioactive decay, K, the rate at which we decay at, that's this decimal number here. This is just a percentage. It's a little tiny bit. Apparently we lose what? You got to think about this. This is 23 thousandths. So that's a little tiny percent, right? This value K will always be, always for radioactive problems, it'll be the following. And ignore this for now. K is always going to be equal to the natural log of 1/2 divided by the half-life. Every single time. Always. Radioactive problems is how it works. Cool. I'm going to zoom out so I can try to straighten this out. It'll get small to read for a second. I'm just going to move, I don't know, just this piece over. All right. This feel okay, feel awful. Should we do another radioactive problem? Do you want to see one more type of problem that we can look at with these? Love it. Cool. I'm going to switch this problem up a skosh. We're going to use just a different problem. Anybody want to work with a specific element, or we just want to make one up? What's your favorite radioactive element? Okay. I have no idea what the half-life is. You want me to make up a real number? We're just going to make up an element instead of Googling stuff. We don't have to Google it. Check it out. We are given the following. And I think this is going to be the last problem. We'll probably do one like pure math idea here. How about radon? I know that one. Cool. So example, is this C? Okay, this is going to be another radioactivity problem. Radon 226 has a half-life, I'm going to use a little bit of editing magic here for somebody watching the video. Here's our problem, and it's going to keep bugging me. You don't have to change yours, but this is radium. I'm not going to change mine either, but it is radium. Cool. Talk it out. I want you to try it. If you're wrong, that's okay. I want you to be wrong. I really want you to be right. But if you're wrong, it's okay because we're going to figure out where. I want you to start setting this up. The one thing I think it would be convenient if we all agreed with is let's just use y equals ae to the kt. Cool. Talk it out. If you can find the stuff you already know, and you don't have to set up like a physics problem, I'm going to give you a second. I'm going to come push people along the way as needed. But if you're watching this video at home, pause it now, try to work through it. You will see and watch a detailed walkthrough in like 5, 4, 3, 2, 1. Check it out. Right off the bat, I'm going to just note the couple things that we know. Ken, can you tell me what A is for this problem? And what is the actual initial amount that we're working with here? Good. I'm going to include kilograms, but it's not going to show up in the mathematics that we do. All right. I need to know A. That's a huge part of the model. Is there anything else that I need, Barsega? So you're absolutely right. I'm going to suggest, though, that instead of writing the half-life, because this isn't a physics problem, we're just applying it, I realistically, not realistically, I need this K value. Would you guys agree with that?
Yes.
And I know that no matter what, if I'm dealing with radioactive decay, this value of K can be found by taking the natural log of 1/2 and dividing it by what in this problem? 1620. I am pretty confident this is a ridiculously small number. I'm not going to change it. I'm not going to type it into my calculator yet. I will hold off on it. This is a value of K. What am I trying to find? So I'm trying to find time. Do I know anything else? I got this knocked out. I know that. I don't know this. Do I know this? You say no, Angel, but reread the problem. How long until what? So what's the final amount that I'm after? Y is 1 in this problem. As soon as we plug this in, and let's just see what happens. 1 equals AE, so that's 50 times e to the, and this is ugly for a second, natural log of 1/2 over 1620 times t. Can we solve it for t? Alternatively, this is when we plug in and then solve. I always advise that we do it this way. It is entirely up to you, though. I know I'm solving for t. So if I do y over a equals e to the kt, I then take the natural log of it, right? All right. So this would be natural log of y over a equals kt. And then t would this then be the natural log of y over a divided by k. We did the exact same thing. I've just solved it before plugging stuff in. If I do this here, Kalisha, notice what happens. Right off the bat, it's 1 over 50 equals e to the this nasty thing, right? Natural log of 1/2 over 1620 times t. And then if I want to solve for t, how do you undo the exponential? I couldn't quite read your lips. What's the opposite of an exponential? That's the opposite of a square or a square root. Yeah, I'm going to take the log. So I'd get the natural log of 1/50th equals, this thing just moves out front and it's ugly, but natural log of 1/2 over 1620 times t, right? Notice this is the same thing. I'm now just going to divide by k, which this is k. I would rather do it here. I'm going to give you guys a second. The calculator stuff gets ugly. Check with your neighbor once you get an answer. I'm going to get my answer as well. I'll pause it for a second because I'm going to type it in the ugliest possible way. This is how I would type it in my calculator. Now it's ugly because there's so many logs and stuff, but all I'm doing here is I'm just plugging in my values. Y was 1, A was 50, cool. I then divided by K, but I know that this is K, natural log of 1/2 divided by 1620, but then I have a fraction, log divided by a fraction, right? So I just multiply by the reciprocal. When you type this in, this is the way that I would type it into my calculator, but you have some options in how you do it. What do you come up with? We're gonna see how many variety of answers we get. 143?
No, 9143.
9143?
0.0.
0.01?
4.
4. Somebody seconded this?
I think I did.
Something different, Bea? Okay. So that's all fine. Like, I'm good with the math. What's it mean? After I'm going to say approximately 9,000 years. 1 kilogram of radium-226, we're going to write this a little bit differently, is left. Cool. The first time we did a problem, it felt pretty nasty, I think. Did this feel easier now that we're starting to work with it a little bit, or is it just as bad?
Not with this particular one here.
So is it just the typing it and getting the stuff? That where do you feel like it's getting challenging in here?
Where I just
Are you cool with step 1?
I'm fine with it.
Are you cool with step 2? Now,
I guess so. I just don't.
so I'm gonna suggest
I
something.
just don't think I would think of that.
And that's okay, but check this out. If you don't like the idea of working with all these logs and stuff, you can do more work, and really it's the same work, but we can change the order so it might make sense. If you're okay with getting to this part, and even if you don't there, if it's starting to get ugly, this is probably the part where it's happening. Somebody hook it up real quick. I need to know the natural log of 1/2 divided by 1620. It's tiny. Negative 0. Whoa, really?
And where does the T go?
Negative 4.
4.27.
Give me a couple more.
86.
Okay. If we had done this instead and taken the time here, notice this would be y equals 50, right? E to the negative 4.2786t. It's the exact same thing. I'm just carrying this through on my calculator so that I round to like as many decimals as possible. If you want to find k here and solve it like this and still replace this with a 1, we can do the exact same thing. It might look easier. I think it looks uglier, but that's subjective. That's my opinion.
Where's the T go on the right side?
On the right side. Nowhere, I just quit writing it. Because I had t isolated at that point. So I knew that anything left that I was doing was just going to be t.
What about the 620?
The 1620
Yeah, 1620. Right below that one.
equals t is still here. It's just when I take a divided by b over c, I know that that's ugly. But it's the same thing as doing the woe, where we multiply by c over b.
How did you take the 1620 out of the expression?
I didn't. It just multiplied. So dividing by a fraction, remember, is just multiplying by the reciprocal.
Oh, okay.
So I'm just showing all the like legit math without having to plug in any numbers because I hate touching the calculator. Is it okay if you touch a calculator step 1 and just plug in from there? For sure. I have one more problem that I want you guys to not just try, but I want you to work it out. If your group just sitting near each other can't work it out, physically stand up, use your legs to move around, and go join a group elsewhere. I'm going to let you guys work it. I'm going to mute my screen. I want you guys to do the same. This problem is going to feel different, but I promise it's not. And we're going to sneak it in right here.
Did you get a tattoo?
No.
I've never noticed that.
I wear a watch every day.
Oh. Yeah, I was like, wait, did he get it?
What do you mean? It's an 8.
Oh.
No, I'm messing with you. Okay. I don't understand. What do you mean? What does it mean? I like math. Yeah, no, I don't know. I was seeing a gal that did tattoos about 15 years ago, and I happened to be studying math, and she did tattoos, so boom. It's fading pretty bad. These ones almost completely fell out as well. I'm going to get them redone.
This one's in your figures, yeah.
Yeah, I'm going to do it with just bold lines. Anyway, here we go. One more problem. Example. I want you to find an exponential model through, and how nice of points do we want? I'm going to let the book do it so they're like middle of the road. I want an exponential model through, doesn't give it to me. What's your favorite ordered pair that's not the origin? And not 0, 1 or 1, 0. Okay, 1, 1 and way bigger. 795, I heard. Cool. You don't got to graph it. Just to show you, if I give you 2 points, typically you're going to be expecting a line. A line would suffice. However, don't graph this if it's brown, pencil down, right? Is that brown to you or is that more yellow? Didn't I make it brown? That's not brown.
Right there. It's between the...
Is that brown?
No. The fourth one.
Hey, there it is. So check it out. If we graph this, and notice I'm not putting a whole lot of thought. 1, 1's like here, and 795 is like way up here. Is there a line that could run through them?
Possible.
Yeah, but I specify that I don't want a line. Do you think it's maybe possible that a curve exists that fits through them too? You're finding me that curve. We did not do a problem exactly like this. However, if you look back, the way I've been writing stuff, especially with examples A and B, you have everything that you need. We're just taking a step into the pure math land for a minute. I would use the form, and it's up to you entirely. I would just call it AE to the KT if you wanted, or we can call it AE to the KX if that would make a little bit more sense. Cool. Try it out. If your group isn't super productive, find a different group. Cool. As we look at these, I get 2 ordered pairs. I know that a 1 spits out as a y when I plug in a what for x? 1, and a 95 spits out when I plug in a what for x? So I don't care which way we start. It's pretty natural when people do this to do the first point first. If I plug in this x and this y from the order pair 1, 1, my equation becomes 1 equals AE to the k times, what am I plugging in for x? 1. And that's just k, but it's 1. Could we solve this for a? What would you divide both sides by? Good. So a is just 1 over e to the k. Are you guys okay with that? We used this first point to get that value of a. I can't tell you the number that is yet, but if we knew what k were, could I get that number? 1 over e to the 5, maybe? Like, that would be a number, right? Unfortunately, I can't yet. However, check it out. Do we have another x and y that I can plug in that fit into this model?
Yes.
95 spits out when I plug in what for x? So instead of writing k times 7, I'm just going to write 7k, because I know that that's what it's going to look like anyway. In this situation, I still have 2 unknowns, yeah? And that's the issue. If only I knew a way to write a with only values of k in it. Oh my gosh, it's right here. I can see it. This is how we can write a with only k's in it. So if we go one step further, we get 95 equals 1 over e to the k is my a value, times, what are we still multiplying it by? E to the 7k. And I think we can solve that for k at this point. When I have e to the 7k divided by e to the k, what do those exponents do? Careful. Adding if we multiply. We're dividing here. So I can see the confusion. Let me clear this up. We are multiplying, right? But if I wanted to rewrite this, this is really over 1. Would you agree with that? I would not take the time to actually do this, but if I wanted to write this as a single expression, it's e to the 7k over e to the k. Because I just multiply straight through. And what do these exponents do? That's where it was just a language thing. E to the what are we going to wind up with? If I had 7k over k, 6k? How do you get that k out of the exponent?
Log.
I like the log more. What log base would you use?
Okay.
Because e to the 7 over, this is just my exponent property for division. I would take the natural log. I'm going to do it in one step, I think. The natural log of 95 would be equal to 6k right now. We're going to take a big leap. Could I divide both sides by 6? You can get a value for k, right? I have no idea what it is. I just made up this problem.
Points.
0.78, sorry. K is approximately, can you go again, Sean? K is approximately 0.7589. Now, a few moments ago, I made a comment that we could get the value of A if we only knew what? Hey, we do know K now. It's this. If we plug it in right here, could you get me value for A? 0.46. Is that a 1? Okay. I don't know. I heard it from over there. Do you now have enough to plug in for this A and this K and get a good model? We done. This is the exact same as a bacteria problem. It's just no context this time. Just pure math. Doable. Probably more so with a little bit extra practice, which, don't worry, I got you. Everybody loves word problems and only word problems all the time, right? Good. All right, your homework tonight is not crazy long, I don't think. I'm going to try my very best to not make it super long. We're going to call this homework 3.5, and we'll make it short because that's the last one of the entire chapter. Okay, homework 3.5. I want you guys to do problems. That's a good point. 245. I want you to do problems 26.
That is short, Holloway.
I like the approach. Good effort. We better do 33. Yeah, I'm cool with 33. I'm looking for a radioactive. 38. Boom. 38. Those three.
Thanks.
Oh my gosh, there's so many cool problems that we could do. I'm okay with just these three though.
That's all good.
All right. Heads up, couple like really important things. If you don't love your chapter 2 test, one, it's kind of a long time since we did it, so if you haven't handed in your reflection and stuff yet, I would make changes with the way you approach those moving forward. So tomorrow, just so you guys know, we're doing team test in class tomorrow. Whether it's a team test or just a review, I don't care if it's graded or not, doesn't impact me.
When are we doing it?
Tomorrow, which would mean tomorrow's Thursday, right? Review day Friday. Oh, this is going to work perfectly so that I can hopefully not give you guys any assignment over the Thanksgiving break, and you'll be thankful for that. Planning on test Monday. That's the intent. Cool. If you need to retake your chapter 2 test still, talk to me. If you don't have your reflections done yet, because you're struggling, come talk to me. If you want to take a version of it, just come talk to me. If you have any questions, concerns, you want to do something to improve your grade, it's going to be mathy, but I have those opportunities. Cool. You guys have 5 minutes to start working right now. I've given you all large note cards. I would not commit to doing the entire note card yet. If you have a little spare time tonight, I would suggest work on some of your note card. I will make a note card as well that we'll compare with, but I don't think we're going to go quite through the same way that we did the previous one. If you personally want to, I'll do that, like we can do that together. But I would start a little bit on the note card,